ask you guys to find intercepts. Nicole, how do I find an x-intercept? Uh-oh. Nicole, there is no y up here. Where's the y? Go where? F of x. Thank you, Nicole. Jason, how do I solve a quadratics? Because obviously, like, 6 out of 10 students didn't know how to do it on the test. Quadratic formula. Jason, tell me the quadratic formula.
Negative b squared b squared minus 4 and a and c over 2a.
So I have the plus or minus there. So I have x equals negative, or opposite of 2 plus or minus. Those are my a's, b's, and c's. 2 squared minus 4 times 5 times c, which is negative 1. Come on, mister. All over 2 times 5. Simplify that. Opposite of negative 2 plus or minus 4, and then this is negative 4 times 5, which is negative 20, and then negative 20 times negative 1 is positive 20. Over 10. X equals negative 2 plus or minus square root of 24 over 10. That is 4 times 6, so this will be x equals negative 2 plus or minus 2 radical 6 over 10. And then you can factor out a 2 there. Negative 2 times positive 2. Negative 1 plus or minus radical 6 all over 2 times 5. And you get x equals, those 2's will cancel, negative 1 plus or minus square root of 6 all over 5. Raise your hand if you got that. Nice. What does that mean? If you just put in your calculators, negative 1 plus square root of 6, divide my answer by 5, and I get point, let's round to the hundredths, to 9, and then negative 1 minus square root of 6 divided by 5 gives me negative 0.69. And let's go ahead and find our y-intercept. So finding the x values did take us a lot of work. Y-intercept is x equals to 0. So 5 times 0 squared plus 2 times 0 minus 1. So 0 squared is 0. 0 times 5 is 0. 2 times 0 is 0. So you're just left with negative 1. 0, comma, negative 1 is my y-intercept. Raise your hand if you got that. Good job, you. What else do we have to find? Domain. Okay, so think about this. Is this a rational function, class? Everyone say no. Because there's no fraction. Right? There's no polynomial divided by a polynomial. Do you guys see a square root? Okay, so that means that I don't have to do any not equals to 0. That means like I don't have to do greater than or equal to 0. That basically means you could pick all numbers. What numbers can you pick? All real numbers. Think about that before you even have a visual. You could pick any x value, positive or negative, and you're going to get an answer. Okay. Let's just say you didn't get it. Inequality, integral notation. Make yourself a quick sketch. So this is going to be a parabola, and it's a U. A value is positive, so it's going to be opening up. 0, -1 is going to go through here. Let's do that again. You're copying this down, your heads are up. So then I have these two values, 0.29, something like right there, and -69, something like that. And remember, I'm looking for the minimum will go through, it's got to be in the middle. So I don't think this is our minimum at all. So I think it goes somewhere. So my graph's going to look something like that. And then our domain goes from left to right, so arrow to arrow, so -infinity to positive infinity. Remember, it does not matter where the arrows are pointing to. Inequalities basically means you could pick all numbers, all real numbers. So if we did set builder notation, you could say in all the values of x, you can pick every single number. All real numbers. For the range, I'll use the calculator for that one. Put that into your calculator. 5x squared plus 2x minus 1. Zoom 6. That's what our graph looks like. And then you can have the calculator trace the vertex. Everyone say vertex? Vertex is basically where it's a transitioning, going from decreasing to increasing, which is the words we'll be using today. So there's our vertex. It's a minimum, so I'm going to do second trace, and I want to calculate the minimum to the left of it, to the right. Whoops, way too high. It's okay. And then our exact guess. Then here it has an answer of negative 0.2, comma, negative 1.2. So that means when I'm coming from the range, bottom to top, I'm here, that number is negative 1.2. So my answer is y is, if you use set builder notation, all the values of y such that y is greater than or equal to negative 1.2. And then interval notation is just starting at negative 1.2 and going towards infinity, because the last thing I touch is my arrows. So we did a whole host of things there. This is what we've been learning for the past couple of weeks, and we did it all in this problem.
Hello, man.